All right, this time we're doing the Unit 8, Lesson 13 practice. It's about these box and whisker plots. Sometimes they're just called box plots. I learned them as box and whisker. When we get to the first one, I'll re-go over how the parts work, like when we get here. These can be kind of tricky because they give you certain information and don't give you certain information, and sometimes it's a little weird to try to figure out what you can conclude from them and what you can't. But and I make mistakes on these every now and then too. So, but we'll get through it. First, we got a little review with fractions, decimals, and percents. So you've done like we're at the very end of the school year by now. You've done a million of these, right? Like, I hope you're pretty good at these. I hope I don't have to do this whole thing for you, but we can do a couple. So let's see here. Fraction, decimal, and percent. If I want to go from percent to decimal, so each one of these is separate. It took me a second to realize what was going on here when I looked at it. Like these are separate here, so you need to fill in a decimal here that goes with these two, and then these are separate, and so you need to fill in a fraction that goes with these two. All right, so to turn a percent into a decimal, just move that decimal point 2 spaces. So right now, this is just the number 80 with a percent symbol, and so the decimal is right here after the 0. But if you were to move it 2 spaces, let's see if we can zoom in a little bit. 1 space would put it between the 8 and 0, so you'd have 8. And then 2 spaces would put it in front of the 8, so you have 0.80, and that's what we want. That's the decimal representation of 80%. And you could leave that 0 off if you want. You could have 0.8. 0.6 repeating, or 66.6 repeating percent. That's one of those ones that I would hope you're just sort of memorizing by now, because trying to turn either one of these into a fraction using any of the like techniques we've been learning is going to be tough with like a repeater decimal like that. And so I'm hoping, just after having been doing this stuff all year, you've got this memorized, that that's 2/3. If not, work on memorizing that. Okay, I'm going to leave the other two for you to do. Yeah, I'm going to leave the other two. All right, so box plot, aka box and whisker plot. It's a way of showing data over a range without like having to put a bunch of dots, right? These are, those dot plots that look like this. Let me use the back of this paper, where like you could have a number line just like the ones on there. Maybe it goes 20, 30, 40, 50, et cetera, et cetera. And then, oh, I'm off the screen, my bad. And then, like, I don't know, maybe you asked some survey about something and like 2 people said 20 and 4 people said 30 and 4 people also said 40, but 7 people said 50. 5, 6, 7, right? These box plots are supposed to be a way of summarizing this data without having to show all the dots, without having to draw them. So behind, like sort of hidden in this box plot, is a bunch of data. But what we know from this box plot is that the lowest data from the whole thing, the whole data set that somebody recorded from something, is right here. That's your lowest piece of data, right there at the left end of what I would call the first whisker. And then your highest piece of data is right here at this end. And then this line that's right in the middle of the box, that's your median piece of data. And the median is, if you were to count or like list all of the pieces of data in order and then pick the one that's right in the center, that would be your median. Sometimes you wind up with 2 that are in the center if you have an even number of data points, and then you just take the average of those 2 numbers, like the mean average, add them up and divide by 2 or whatever. And so there could be a piece of data that's right here on the median if there were an odd number of data points. Then this median line would represent a very specific piece of data. If there was an even number of data points, then this median line still could represent actual data at the median, because you could have the 2 middle numbers were right there on the median line, and so they wind up being the median together. But it could also represent 2 pieces of data that weren't on the median line. Like So you can't necessarily always assume that there was actually a piece of data that fell at exactly 150 to $50 price for this one. Most of the time there probably is, but not every time. That's what can get sneaky tricky about these things. All right, and then on these box and whisker plots, this thing's essentially broken up into 4 spots, right? Let me see if I can use 4 colors here. So the first section, I said spots, but I should have said sections, is right here on the first whisker. This represents the lowest 1/4 of the data, or the lowest 25% of the data, I guess if you want to call it. And so we call that the first quartile, but this piece of data right here at the first line, I guess we really call this the first quartile, 1Q, because like 1/4 or 1 quartile of the data is like below it, and all that data sits on this kind of purplish line. And then I'll use orange. This in here would be considered the second quartile, because the second fourth of data all lives in this part of the box where I squiggled orange. And the second quartile number is essentially the median. Now, the third quartile of data, the next fourth of values that are higher than the median, all live here where I'm squiggling green in the other side of the box. And the ending line of the box right here is called the third quartile number, because 3/4 of the data from this data set is below it. And then the fourth quartile is just the last whisker, which in this particular data set is very, very short, right? And the length of each of these quartiles is an indicator to you of how spread out the data was in that quartile. The first and second quartiles are pretty long. So that means there was a lot of spread along the data in those first 2 quartiles. Whereas the third and the fourth quartiles are much shorter. And so there's the same number of data points in those smaller quartiles. They're just scrunched together more. All right, so, and there's one last thing that we call the interquartile range, IQR. That is a measure of how spread out the data in the center of the data set is. They're essentially asking you, how long is this whole box? The whole box, the green and the orange part. A longer box there means more spread out data, and a shorter box means more scrunched together data. So this box goes from 100 to 175. So the range of this box, aka the interquartile range, is 100 to 175. That's 75. It's the distance, 75. One way you could do it is this number minus that number gets you the IQR. So I'll write it like that. 175 minus 100 gets you an interquartile range of 75. And the median, that's right there at 150. That one's not too challenging to see. All right, so that's pretty much everything you're expected to know about these box and whisker plots in 7th grade. Hopefully that was a good review for you. I'm not going to do that for every one from here on out. Now I'm gonna do the rest as if we kind of already talked about it a little bit, right? Okay, so, and in fact, I'm going to leave this one for you to do. Use this one as your guide to finding the median and the interquartile range for the second box, and I'm going to move on. I should say the second box plot, not the second box. Zoom out a little bit. Well, no, I guess we're good. Kai wants to understand how long it takes for students to get to school using different methods. We did one just like this in the lesson in class. Well, most years I do that. I guess there could be some future year where we don't, but whatever. On 2 different days, he asked 10 random students how long it took them to get to school. Okay, so we have a box plot for the first day he asked, which was Wednesday, and the second day he asked, which was Friday. Or I guess it could have been the other way around, Friday and then Wednesday, but whatever. For each method, write a rough estimate for how long it will take students to get to school on their next trip. Okay, Well, this whole graph is for walking. And we have two data plots, two box plots in it. One for data he got on Wednesday and one for data he got on Friday. Now, when we compare them, they're relatively similar. Yeah, the lowest number is considerably lower on Friday than it was on Wednesday. And the highest number is a bit lower than it was on Wednesday when you look at Fridays. And the boxes are a little bit more spread out on Friday, but when with all things considered, these are pretty similar. Now, if you only had one of these plots, like maybe we only had the Friday one. Ooh, I'm trying to use this. Let's say we only had the Friday one, and you asked me, make a rough estimate of how long it takes. Well, I would just use the median. I'd be like, well, the median's in the middle. That's a rough estimate. But now we have two medians to consider. We got a median and a median. Well, how about we take the median of the medians or the average of the medians? What is this median looks like it's at about, I don't know, it looks slightly lower than 30, 29 maybe. And then this one is, it's hard to say if it's on 33 or 34. I'm going to call it 33 only because I know that'll make my life easier when doing these averages. So if the Wednesday median's at 29 and the Friday median is at 33, then using both data sets, we can make a reasonable estimate of approximately how long it should take someone to walk to school by taking the average of those two. So 29 plus 33, that's 62. And then since there were two numbers that we added up, we take this and divide it by 2 to get the average. So then 62 divided by 2 is 31. You also could have just figured out that 31 is right in the middle of 29 and 33, and it would have got you the same answer. So my answer here would be, my rough estimate is 31 minutes to walk to school. Now the bus, on the other hand, see, these two aren't like each other at all. These are very different box plots. The shortest time on Wednesday was way longer than like the third quartile number on Friday. So it's almost like I want you to try to think, why would the data look like this? What maybe was different on Wednesday compared to Friday? I'm giving you a few seconds to think about it. I'll tell you some ideas I have, but I want you to think about it. Pause it if you want more time to think about it. So maybe there was crazy traffic on Wednesday. Like maybe there was an accident, and so the bus had to wait super long. Maybe all the buses had to wait, so they all got there kind of later. Maybe a bus broke down. I don't know, but something caused Wednesday to be longer than usual. Now, you might ask yourself, why am I concluding that Wednesday took longer than usual instead of saying that maybe Friday was shorter than usual, right? Those are two different conclusions. Well, I think Wednesday took longer than usual. I think Wednesday took longer than usual rather than Friday was shorter than usual, because the way the Wednesday data is so grouped together so tightly way up here. That to me indicates that like all the buses came late. Like there was something happening that caused everybody to sort of take 45 to 50 minutes. Whereas it would be strange to me if there was something different about Friday that caused some people to somehow get there in 0 minutes. How does that even work? How does somebody get to school on a bus in 0 minutes? This to me, this person they asked didn't understand the question, or they lied or something. And 55 minutes, like, I don't know. I could be wrong, but I'm just trying to, sometimes you got to just kind of logically think through some of this stuff. Anyways, I think you could approach this question in different ways. I think you could approach this question by saying, well, look, we'll just do the same thing. Let's take the median of the Wednesday median and the Friday median and just, we'll call that a rough estimate. If you did that, I would accept that as a reasonable answer and it's justifiable. But that's not the way I'm going to go. I'm going to say, look, I don't believe this Wednesday data. I think this Wednesday data is janky for some reason. And this Friday data is something that I could probably just hopefully generalize from. And I'm going to say the Friday median is the best median of how long it really takes somebody to get to school. And so I'm going to say 12 minutes. Sometimes it's as good as you can do with this stuff. And so 2.2 says, which estimate is more likely to be accurate? Explain your reasoning. I think by far the walking data is going to give us a more estimate, a more accurate estimate, because we have 2 days that look about the same. And so like the data feels more reliable or repeatable. Whereas with the bus, the days are so different. We don't really know what's happening here. Some of this data is throwing us off. And so definitely the walking data is going to be more accurate. And I want you to write an answer here that summarizes essentially what I've been saying this whole time, please. And I'm going to move on. A video game developer wants to know how long it will take people. Sorry, I don't know. I'm reading it off the screen. I can just read it off the paper. How long it takes people to finish playing a new game. She surveyed 2 random samples of 20 players and asked how long it took each of them in minutes. Okay. Estimate the median time it takes a player to finish the game. Okay, so just like before, we got 2 sets here, 2 data sets. But good for us, they're really, really similar. I mean, the third quartile is like literally the same. The whiskers are pretty similar. This one has a slightly higher median, but I mean, this looks like some pretty good, reliable, repeatable data. So let's do the strategy of let's take the median of the medians and we'll call that our overall median. So the first median is 1,250. The second median is somewhere between 1,250 and 1,500. It looks like maybe it's closer to 1,500. So maybe like 1,400. 1,400 would be a little bit closer to 1,500 than it is to 1,250. So I want the average of 1,250 and 1,400. So add those up and divide them by 2. That's how we find the average of 2 numbers. So 2,650, and then divide that by 2. This is not how you should write this. Writing equals, and then a number divided by something equals. This is bad math writing, but I just don't have a lot of space to work with, so I'm cheating. 1325. See, the reason this is bad is because now all these equal signs, everything on all these equal signs is supposed to be equal. And so I'm saying 1,250 plus 1,400 equals 1325. That's not true. So don't write like this. Don't be like me. Be better. All right, 1325. Now, how close do you think your estimate is to the actual median time? I think it's pretty close. Pretty close. I'm comfortable with that. Unlike I was about the bus data on the previous page, I'm comfortable with this data. How could the developer change her samples to make you more confident that the data is representative of the population? Law of large numbers. The more data you have, the more reliable and more representative of reality your data is. So she could sample 100 people instead of 20 per group. Like maybe she does two groups of 100 instead of 2 groups of 20 or whatever. The more data you gather is always going to, well, I shouldn't say always, but generally speaking is going to get you more reliable, better data. But then you have the toss-up, geez, I can't think of the word I want, but if you want more data, that's great, but then you have to work for it, right? It takes more time, it takes more money, it takes more resources to get more data. So that's why we sometimes settle for lower numbers of data when we're surveying and that sort of thing. All right, lastly, the recipe for a signature pizza uses 3 cups of cheese. Sorry, 3 cups of cheese, 3/4 cup of olives, and 1.5 cups of ham. Olives and ham. How much cheese, olives, and ham is needed to make 10 signatures pizzas? Okay, so just multiply each of these by 10. You need, for cheese, it's going to be 3 times 10. And for olives, I'm just abbreviating, CH for cheese, OL for olives, it's going to be 3/4 times 10. You can write that as 3/4 times 10 over 1. And ham, big old H for ham, 1.5 times 10. You could change 1.5 to 3 halves or 1.5. Most people like 1.5 better, so I'll go 1.5 times 10. That'll get you your answers on those. All right, lastly, we got an explore. Here are 3 box plots of the same data set on different axes. Ooh, this is weird. Okay, so this box plot, this box plot, and this box plot all represent the exact same data, but they look stretched because the axes, how the numbers down here are different. If you put the numbers closer together, if you use like 1, like 12, 13, 14, 15, 16, 17, then things will get really spread out because you got to cover a lot more numbers. But if you use bigger numbers, if you go 100, 200, 300, 400, then everything will get scrunched together because they don't have to cover as much to go far. So see if you can fill these in and then use a pattern to fill in the axes properly. So certain numbers aren't going to change. Where this whisker starts, where this whisker ends, that's going to be the same number on every one, no matter what the axis is. The median is going to be the same on each one, no matter what the axis, how the axis is labeled, because the median is the median is the median. So this median looks like it's at 24, 26, 28. Nah. I don't know. It's hard to say. Is it 26 or is it 28? I'd probably go 28. So if that's 28, then that means that this has to be 28 and that this has to be 28. And now, what's this first whisker at? That's supposed to be 20? It's hard to tell. But okay, let's say it's 20. Then that means that this has to be 20. And this has to be 20. Okay, now this one is pretty easy now because of it. Look, you got, if that first whisker is at 20 and the median's at 28 and there's one line directly between them, then do you see how that has to be 24? And then every line from there has to be 4s. 4, 4, 4, 4, 4, 4. This one's a little bit trickier, but I'm going to leave it to you to try to figure out. Remember, just don't leave it blank. You got to at least try it. If you can't figure it out, you don't get it. That's all right. I'll see you.